My name's Ian McDonald. I'm the director of the Tallwood Design Institute, and this meetup series has been something we've been doing for quite a few years now. I think since 2017, we kind of moved online during COVID and mostly stayed that way, although we occasionally do organize in-person events in the Portland metro area. And I see people joining from way outside the Portland metro area today. So thank you for doing that. And we were previously using the Meetup platform to manage our RSVPs and announcements, and we've just transitioned away from that this year. So hopefully you found us okay if you were on the other platform. Um, so let me just introduce the topic today. We wanted to ask our colleague Lech Muszynski from OSU Department of Wood Science and Engineering to come and talk to us because you might know that OSU and the Tallwood Design Institute leads something called the Pacific Northwest Mass Timber Tech Hub. And that's a regional organization across four states of Oregon, Washington, Idaho, and Montana that is looking to kind of convene and speak as a unified voice for the industry and advocate for programs and resources that will boost this region from kind of early adopter of mass timber in the US to one of global competitiveness within a sort of 5 to 10 year trajectory. So that's our goal. And we think a lot about um, what is being done in other parts of the world, what manufacturing looks like, what the business strategies look like, factors responsible for competitive edge in different places and the way that mass timber has kind of evolved in different places. And so the perfect person to have on to consider this is like he, first of all, is one of probably the earliest. Well, I don't want to go out on a limb and here and say this, but he's certainly one of the earliest people I'm aware of to get involved in researching mass timber in the United States. Um, and for many, many years, Lech has been touring mass timber manufacturing plants. He's been in more manufacturing plants than I know, and anyone else I know. And so we wanted to give him the opportunity to sort of um, present some observations based on those travels, based on what he sees in different parts of the world. And like, I'll let you describe kind of where you've been recently and how many plants and all that kind of stuff, because I'll get the numbers wrong. But I just wanted to set the scene there and turn it over to Lech. So we'll probably talk for what, 45 minutes, something like that, Lech? Yeah.
That would be the time frame.
Okay.
Unless you interrupt me with questions, then it's going to get longer.
Sure. If anyone has a real burning question, Parker and I will be monitoring the chat, so we can maybe flag that for Lech at an opportune moment. And otherwise, if you want to wait till the end, we'll try and reserve 15 minutes for questions at the end. And also, I feel underdressed now that Lech is wearing a sports jacket, so I just wanted to apologize for that. And without further ado, I'll turn it over to Lech.
Thank you very much, Ian. It's a great introduction. Essentially, at this point, I should bow and leave, right? um,
Please,
yes,
please don't.
as long as our ambition is to be globally competitive in the mass timber industry, and particularly with mass timber panels, it is necessary to just check out and see what's the competitor, the globe is doing. But before we get there, I would like you to answer a couple of questions for me. You now know who I am. If you could just scan this QR code, this leads to no more than three questions, and we'll try to see what's the who participates in this conversation. So once you have this QR code is going to stay on the side here. Who are you? Are you an architect, engineer, manufacturer, contractor, investor, academic, student, other? If you defy categorization, just choose the other. It's coming up pretty nice. I see the architects and engineers leading the uh, share. Now, academics, 20%, not bad. 19. Students, welcome, guys. Consider with science and engineering.
Yeah.
Very good. You can keep doing this even as we are moving to another question, right? So how familiar are you with the CLT technology or industry at this point before we even start this talk? This is going to let me know how much I need to explain. This was nice, all at once. Very good. For those of you who have hard time seeing the options, the first one is I'm familiar with the principles of CLT. I have visited some CLT buildings finished, right? Or I have visited some CLT construction sites, which is a very different experience, I must say, right? I have visited a CLT manufacturing plant. It's still different experience. I have been involved in a CLT project that would be like top badge and out and start asking questions on what and how.
We have one person saying it's not an option, but I'm fully unfamiliar.
That's
Here
okay.
in-
I can't believe that. I bet there is a level of familiarity. If you've ever been in PV Hall, you're already familiar with this technology. But if you haven't, you have to. Okay. So again, while you can keep responding to this, we are moving to another one. For those of you who have opinion, please share what would you consider to be the major barrier in building with CLT right now, right here in North America, or more specifically in the United States? And if you could respond with just one to three keywords, not perfect sentences, this would be cost, familiarity. This, to be sure, are recurring themes. Nice. Very good. So if you keep feeding this thing, right, these outcomes of the survey are going to be added to the record of this presentation. So now let's go back to where we've been. This is my QR code. If you ever wanted to check more about what I am and what I do. So mass timber, these are like the prime examples of what comes to mind where we speak when we talk about mass timber, like from the forest to the tallest buildings ever made by human in wood, right? The Ho in Vienna, the tall building in Norway, who once have been the tallest, Milwaukee building, who may still be the tallest mass timber building in the United States, right? So these are the prime examples. This is what we are proud of, right? The white unicorns, things that stand out like Eiffel Tower, right? And demonstrate the ability of the industry. Now, I'm also fascinated with large CLT building, not necessarily tall. I mean, this is or used to be the largest by the amount of CLT consumed, here expressed in cubic meters, right? So this is compared with the total usable area of this building, a nice size, right? I would like you to keep this number about 4,000 cubic meter in mind, because it's going to be an important measuring stick. So all of this is enabled by panels being cross-laminated in 3 or 5 or 7 or at most 9 layers that I've seen. I mean, I've heard of people doing 11 layers, but I have not seen them yet. And this being turned into massive panels. The production overview, I mean, there is no magic to this. If you think about it, it's like raw material reception area. This would be like with glulam, right? Nothing different. Finger jointing, just like glulam. Planning and cutting to length. Planning is necessary after finger jointing to have like a very smooth surface. Again, not much different from glulam. If you're familiar with glulam. Then long pieces go one way, cross pieces go the other way. Long pieces would be in the major strand direction, and the cross pieces would get into these transverse layers of the pan. And then they get light up. I mean, lying up needs to be like one layer of lumber, then layer of adhesive, another layer of lumber. This would be the cross layer, another layer of adhesive, another long layer of lumber, and so on as for as many times as many layers you would need. Followed by pressing. These are large area presses that first pop up specifically for this kind of products, right? There wasn't anything like this on the world before the CLT arrived. Well, there were big LVL presses, there were big plywood presses, MDF presses, but nothing of this size and nothing of this capacity. And at the end, the panels are being CNC machined and finished. The result may be quite impressive. It's about 13 feet, up to 13 feet in width, 65 in length. This would be about half of a thousand of a cubic feet, right? Or I'm more familiar with cubic meters, so it would be about 14 cubic meters. May weigh about 5 tons a piece and be quite expensive a piece, which is going to be important as we go further. Now, this bulk, the mass of timber, gives it the unique fire safety feature, right? It does not burn easily, and it's not easily engulfed in flames. It's being exposed. It's exposed to fire just from one side. So this is an attribute that we like to brag about. And then CNC machining allows us to cut it in all kind of intricate ways. This is important because panels, when you work with glue and with beams, beams need to be elaborated at ends and at places of support, but this is it. Now, panels need to be connected with other panels, and then they need attention around the perimeter. And then you may want to cut openings in them, and some of them do not have to be rectangular. All of this can be done on big CNC centers. If you don't know what it is, it's like large robotic frame that handles machine cutting and machine finishing tools, molders, saws, and follows a pre-designed shapes, can cut at any angle you may want. Now, essentially, this is an old story. If you think of the technology, there is not much new in here. The cross-laminating of wooden elements has been known since Egyptian times, right? They were like cross-laminated slices of veneers used for fine furniture. But the first modern patent for what we now call plywood was issued in 1865. Then followed by the first adhesive bonded glulam used in Europe and in late 1800s. Then in 1905, plywood made an impact at the World Fair hosted by the city of Portland in Oregon, where Ian is sitting right now. Plywood has become shortly a strategic material, right? Used in fighter planes, even in the First World War, even more of them the Second World War. This is actually what propelled the science of layered composites before carbon fibers and glass fiber composites appeared. And then in 1923, we find there was a patent for something that looks eerily like cross-laminated timber, if you look at the figure one. So essentially, there should be no surprises in here. In 2013, architect Michael Green, in his TED Talk, referred to CLT as the plywood on steroids, right? There's like quick connection. The technology generally should not be very conceptually there is no difficulty in here. So today we should not be this should not be a new material for us, and yet the industry continues throwing surprises and posing baffling puzzles for us. And not the least important of them would be uneven pace of developing production capacity. When we look at the global regions, at certain places, it seems to go faster, at others slower, but even more unsettling, the uneven rate of attrition across the main regions. By attrition, I mean some companies fail, and in some regions, more of them than in others. Yeah, things happen. If you look at this list of CLT facilities, CLT plants, lines being closed, repurposed, repossessed, um, collapsed, or burned, or restructured, the list is very long. The unsettling thing in here is that in last 6 years, actually less than 6 years, North America lost 5 major CLT operations. Yeah, they have been restructured, right? But something went wrong in there. The companies could not carry on. Some have closed their CLT lines permanently. The others are in process of restructuring and are continue manufacturing the CLT panels, trying to find different place in the marketplace for themselves. So here comes the global industry survey project. This would be like trying to find what may be the best models or the scariest warning stories, or perhaps bad examples not to follow. What happens in the world with CLT that can help us understand the structure, the production profile, the output potential, the internal diversity, innovation, and competitiveness, and perceived barriers for future expansion? This is actually one of the questions that I ask you, right? And survival tactics, logistics, not least of them all, and employment. So we treat the global CLT industry as a living laboratory that allows us to understand better what both the current state of the industry and its trajectory for future development. It's been funded by, this meeting has been upgraded. Why I'm getting this? Okay. Sorry, there was like a Zoom message that popped up on my screen. This is a long-term project that started in 2013, and over its lifetime has been supported by a variety of sources. And what we do is collecting information by surveys, interviews, and site visits. So let us first establish one thing. CLT is being produced in many places, and trying to discuss the production site by site and plant by plant, line by line, would be rather difficult. It is easier to see things in perspective when we consider what happens in greater regions. And for the sake of this presentation, we are going to first cut out a Central Europe region from the rest of Europe, because this is where the cross-laminated industry has started. It was first conceived, developed, and discussed long before it was picked up in any other place. The rest of Europe is essentially like North America and Australia, South Africa. It's picking up. It's following the suit. But the most important and most interesting things have happened so far in the central part of Europe. So we are going to look at it separately. Then on the other hand, we have this sparse area here in the Asia Pacific, which is being put together from operations in New Zealand, Australia, and Japan, Korea, China, for which we have relatively little information. It does not mean no information, right? It's trickling. And then South America, there are two operations in South Africa, which speaks now for the entire continent. But when we speak Africa, we would mean essentially South Africa, just single country. Okay. So now, in terms of sources of information that are going to be discussed in here, one of the most important and with longest pedigree is the trade journals in Central Europe. Of those, most reliable source of information for me was Holzcourier or Timber Online. It is regularly reporting on cross-laminated timber industry. However, exclusively for this Alpine region, for which they understand Austria, Switzerland, essentially just southern Germany, at times northern Italy. Interestingly enough, because of some of the Austrian companies have operations in Czechia, Czechia is included in this family of Alpine Europe. So it's actually more properly, we would more properly refer to this as Central Europe, okay? The other countries have various level of manufacturing, from token, just one manufacturer, to actually robust industry, but still catching up after this giant. Holzcourier regularly publishes not only the actual production numbers, this would be the brown bars, but also projections. Now, these projections are typically published towards the end of the year. So the publishers have already a good idea of what is coming. And what you see in here is like the first year that shows contraction, not contraction, but the industry leveling off a little bit in Central Europe, okay? Now, by comparison, if you want to see like the scale of how big is this area, it's about the size of California, right? Not the least of the states, not the largest, but this is to the scale. So now the other source is surveys. We've conducted total of 3 surveys, with the first one being most successful with the greatest response rate. And then as we went, probably manufacturers got tired with everyone asking them questions and sending surveys. The return for the effort was diminishing. And you can see that the last survey that we've sent to whooping number of companies, 122, got just 12 responses, 10%. At this point, much better source of information is direct site visits and interviews with companies and company representatives at trade shows and so on. So here you see a progression of my travel and sightseeing in the CLT industry. The gray bars show like the total number of site tours. This includes some repetitions. I've been in 15 plants more than once. And this would be this brown bar would be like annual
Is that I'm
rate
hearing from you now?
of visit. Yes, Judith, you have a question? Okay. So when I interview people, I have semi-structured questionnaire since 2017. Before it was like more open-ended. And this questionnaire is evolving to harvest as much information as I can. Now, in terms of the site visits, quite often, and then I had to make it a blanket policy. I could not take pictures that I could be published anywhere or shown. So I'm going to avoid showing you pictures from individual sites, except for the few that for which I have a specific agreement to share image. Otherwise, I'll be just showing aggregates that will not allow you to track the data back to the original source. Okay. Among these side tours is also the hardware and equipment manufacturers. These are important sources of information because this is where you learn what is coming, what is new types of equipment, who orders these new types of equipment, whom should I talk to next. And anecdotally, this is late Pavel Ledinek, the founder of the company Ledinek, that is now one of the leading hardware manufacturers for catering to CLT industry. So what we learn, first impression of all of this travel is like enormous diversity of this industry. I mean, it's not unlike what you see with glulam, plywood, OSB industry. I mean, there are small variations between plants, but once you have seen one or two plywood companies, one or three OSB companies, you essentially know how the industry is manufacturing the material, right? There is not much more to learn from more visits. You can track news on new equipment coming, new improvements in the technology, but at any given time, most companies would be operating at more or less the same level, and the product would be very similar, which is a hallmark of what we call commodity. Now, when you look even as these samples taken just from my office, you would not see more than two items that are similar to each other, and most of this is CLT. Okay, except this would be micro CLT, and this would be no glue, just nail bonded cross-laminated panel, which, if you insist, may be called cross-laminated timber. Purists would call it something else. But product options would be just one of the places where companies differ from each other. The manufacturing processes, levels of automation, scales of operation, products and services offered, market strategies, modes of interaction with extensive supply chains, all of this is still non-standard, very much from one company, differing and substantially from one company to another. I already alluded to glueless cross-laminated timber, and one of the examples would be mass wood wall, MHM, coming from German acronym Massive Holzmauer. And this is a technology that is based on three pieces of equipment, two of them supplied by Handegger, and operators essentially use Handegger's license. They can produce these thick panels up to 11 or more layers of thin but wide panels, being just penetrated only 3 layers with a fluted aluminum nail like this. All of this is done by robot, so it's a very quick process. The other glueless option and nailless option would be double bonded cross-laminated timber. For a long time, I believed this is just an academic exercise, but no, there are companies that do this in real time. There is a company called Technowood who produces entire turnkey, highly automated robotic production lines for this company. And there is currently about 12 companies doing it that way, mostly in Switzerland and Austria. So this is just as a footnote that what we call cross-laminated timber may have many flavors and beyond what we imagine as a adhesive bonded cross-laminated panel. Another flavor of this picture, sorry, is historic. This company does not do it any longer quite that way. They are still in operation, still do glueless and nailless CLT, where cross-laminated panels are essentially locked in each other mechanically, like wood puzzle. rather than bonded with any physical connectors or adhesives. So I like to compare it to a evolution, right, a process that results in diversity of outcomes, diversity of products, processes, uh, approaches to business. And this is a first cautionary tale. If people travel to this epicenter of CLT manufacturing to Central Europe and for trying to find a model for their business, it very much depends where they go, whom they talk to, because you may end anywhere on this tree of evolution and without seeing the entirety of what actually happens. So what we learn, the state of the industry is strong. No, I'm kidding. Well, this is actually what you would hear from most publication focused on mass timber. I mean, there's a barrage of very upbeat messaging about mass timber. It's green, yes, it's green, of course. It's strong. It's developing, gaining popularity, right? That's my favorite shortcut, like gaining popularity. What do you mean exactly? And the growth is exponential. I would agree with this statement, right? So this is as much as I know from the past until 2013. This would be like data from external sources, and then starting from 2013, this would be accompanied with my data, and both with documented and estimated CLT production across the globe. And it's exponentially rising towards 3.5 millions. This will be like the latest data is for the last year. I mean, I'm a scientist, right? I can fit an exponential line in there, and both to the estimates and to the documented volumes, all of them are reliably exponential, right? So it's been referred to as plywood on steroids, right? I told you that it is. Global plywood output currently is about 140 million cubic meters. I mean, this is estimate from 2023. What did I tell you was the CLT output right now? About 3 millions were the steroids, right? I mean, that's a rather small potato compared to plywood, the most similar, the original idea for this product, right? Okay, are we going there? Well, famously, you can straighten up exponential curve if you put the y-axis, right, in logarithmic scale. So instead of having like million after million, we are starting with 1/10 of a million, right? That would be what? 100,000, right? 1 million, 10 millions, 100 millions. This is where global plywood was in 2021. I should have moved this to 2023 and be probably somewhat higher. This is where CLT is like right now. So it looks like CLT may be at this level about 2050. Well, this is as long if things go really well. The recent slowdown may actually get us to the level of plywood somewhat later in time, right? So this is like first warning. It's not a big industry, right? If we look at the employment, we see the same story. Most of the companies, if you take like the average, I shouldn't say most, but the many companies for which I took data on the employment, they would produce not only CLT but other products. So here on this graph, you would see broken by the regions and then separated for the US, right? And reported for all of the companies for whom I have data on employment. Only part of the crew would work on CLT alone. The exception from this would be US, where the companies that produce CLT would produce nothing else or very little else. So all of the people employed would be employed on CLT. Similar story in South America in here. So this is first. And by the way, this is just a footnote. Contrary to how this industry is being sold as super progressive, the female employment in the industry is rather minuscule. And if you look at who is being employed in there, so management production would consist a relatively small fraction of the employment, but CNC machinists, engineers, designers, salespeople, logistics specialists, administrators would weigh relatively heavy in this employment. And then if we project, because I don't have data for the entire region, I would have to just project this rate based on the size of the company to see how many people may be employed in this entire industry. We said it's about 12,000, not even 12,000, about 10,000 people globally employed for this industry. And then of those who work with CLT directly would be about 5,000 people. It's a small industry, right? 5,000 people globally would not be much. So I like this quote. It's not my own exclusively, right? It's the authorship is shared. More than a decade since launching first structural CLT line in the US, and that would be D.R. Johnson, right? There was pre-existing operation in Montana, but not producing structural CLT. This was access mats. Mass timber remains a minuscule fraction of the construction market in this country, right? But in other countries as well, with the design and construction industry focusing on bespoke, high-profile, high-cost, high-rise projects that have greater impact on public imagination than on forest and built environment. I mean, imagination is important, right? This is what Eiffel Tower did to the steel construction. This is what these large buildings do to CLT. So it should not be understood as diminishing the accomplishments of the industry, but it's an important signal on how we speak about this industry and what it actually represents in real life numbers. It's one of my favorite slides. It comes from a report done by a consortium. Here you have authors Roy Anderson from Beck Group, Erica Spiritus, Nick Sills, and Catherine Salvin put together a report on Pacific Northwest regional mass timber market study. And on this graph, what you see on the left side are all logs being harvested in this region, and then being showing us how these logs are being used in different kinds of products or across the forest product industry. At the bottom of this diagram, you see no other uses, and then mass timber lumber. Of this, how much goes to mass timber projects, mass timber byproducts, project glulam, project CLT. My goodness, this is a very tiny proportion on here. Is mass timber going to clean our forests from lumber? No, not anytime soon. Okay. So this is something to conclude in flight here. This is not the end of my talk, right? The industry is evolutionary very young. It's still finding its sweet spot at the intersection of businesses along the complicated supply and value chains. And it's a radically new concept, challenging commonly commodity-oriented forest products industry models and the linear models of construction projects. We're going to discuss it in a little while. So, and as we said before, it's quite vulnerable. I mean, young age is the age of vulnerability, right? Many things happen, but there is at cost. Let us take a look at this global output and capacity. I already told you it's like, okay, 3.5 million at best right now, globally, comparing to 140 millions of cubic meters CLT. How is this volume being distributed across the globe? Let's see first by the number of plants, right? This would be one way of looking at it. How many plants do produce cross-laminated timber across the globe? And you can see here, like Central Europe, right? These numbers, by the way, I intentionally show you somewhat older numbers, so don't pay attention to numbers, just to the proportions here. About 2/3 of the lines existing are in producing CLT are located in Europe, right? Of those, nearly half in Central Europe. North America would account for a slice in here. Relatively large number of plants in Asia Pacific region, small amount of two. Back then it was like just two plants in South America. Now, very different perspective when you look at the annual output, how much is being actually produced. And then again, in this older survey, it was nearly 80% of this would originate in Europe, almost more than 2/3 in Central Europe. So when you see a CLT plant, it would be like 2 to 3 that it's been produced in Europe. What does it tell you? I mean, it tells you how well the existing infrastructure is being utilized. Okay, these companies in Central Europe, many of them have the capacity to run 3 shifts, and that would be super rare in other regions of the world. Now, per shift capacity may also be an important factor, and you also see that the per shift capacity is like outpacing for European companies. It's outpacing the actual number of facilities. And again, Central Europe performing much better than the rest of the Europe, which I told you is pretty much like what you see in North America or Asia or Asia Pacific, South America, just catching up. So now these numbers change. So this would be the actual numbers for today, as much as the best that we know. So here you would see that there are some more or less substantial shifts in the number of plants installed, more or less substantial shifts in the total output. It's just a couple of years, and you see how North American output increased. Anecdotally, this would be by accounting the substantial production of non-structural CLT that happens in the United States, lumping them with the structural CLT just because the company certified their products for structural use, but it does not mean that all of them are being used that way. And per shift capacity, right, which again increased somewhat from this earlier tally in here. This is a clear image for the snapshot of today. Okay, so keeping in mind, this is the proportion. Essentially, everything that is being produced is being installed. There's like no waste generated, right? All panels being pressed are being pressed for specific projects. So this is reliably a number or the volume of panels being actually installed in structures. Does the size matter and how much, right? So here you would see a graph that shows the distribution of operations. This would be number of operations, right, by the annual output range. So this would be less than 10,000 cubic meters per year. This would be between 10 and 20,000. This would be between 20 and 30,000 and so on. And the largest category would be more than 50,000 a year, which is a large number, right, within this industry, but small compared to the volumes being produced annually by any given plywood company. And here would be like annual volume contributed by the businesses of each scale to the global pie of the production. You see that even as most of the companies existing in the world are small scale, small and medium scale, the contribution to the global blob, the global pie of CLT production would be relatively small. However, I would not like you to look at it as a bad thing. Actually, knowing that you can have a small business that does not operate on the scale of the largest is a still very viable option. There is plenty of them in Europe along of these giants, and they are doing just fine. Okay. This is again how this thing would change. The time difference between the gray, the previous tally, and the current tally would be the same as for the different pies, for the grayer pies, and the distribution of the production between regions. So you see how quickly things may change in here. And then by per shift capacity, right? Again, there's like great number of businesses that have relatively low per shift capacity, and yet they are contributing relatively good volumes to the general production, global production, and still finding a niche in this market to serve to earn the profits. This is again how it would change in a relatively short period of time. So now there is also lots of discussion about what is the best type of fiber, what is the best raw material for cross-laminated timber. As for the North America, the PRG 320, which is the product standard and product performance standard for CLT for Canada and US, the requirements are relatively low. Any species or species combination recognized by ALSCC PS20, this is product standard 20, and anything that is has specific gravity larger than 0.35. This species tend to be listed in an NDS, the National Design Specifications. So the design values for the raw lumber are known by grades. And then the PRG 320 specifies that for producing CLT, it is enough that the longitudinal layers are made of number 2, which is not the highest grade in this market. The highest is selected structural, that is number 1. Number 3 is like the third in the row, right? It's relatively inexpensive lumber. And transverse layers could be even produced with number 3. In terms of species, there is no magic in species. If we look by the number of plants that use certain types of species, so here I cannot tell you specifically what kind of spruces and what kind of pines, because this would make this entire pie illegible, right? So we settle on spruces, pines, firs, and so on. So you would see that spruces are the largest part of the pie, but not overwhelmingly, followed by pines, firs, larches. The key is essentially whatever is available in the region, whatever in given region passes this criteria for the region again, because in Europe the criteria may be somewhat different. So this would be a comparison. The pie for Europe would look much more like the pie for the global pie, is just because about 2/3 of the production is coming from Europe, and the most commercially available species in the Central European region tends to be spruce. Okay, and then in Nordic countries, it's going to be spruce again. So this is what drives these pies, right? By comparison, in US, it would be spruce pine fir as a combination, a little bit of Douglas fir. But that's again, there is no magic in there. Whatever is commercially available, could hardwoods be used? Yes, PRG 320 now has a language that allows hardwoods as well. If we look at by the actual annual output, right? So if we scale this pie by volumes produced, the pie chart would not change much. It would be still spruces, pines, firs would dominate this thing. And this is again because the largest volumes are being produced in Europe. Now, the next misconception is that there is some magic to pressing, right? Now, it's like there are essentially three major types of presses that we see. Hydraulic presses, about 50% of operations, right? So this is by numbers installed, would operate hydraulic presses where the pressure from the top and bottom and from the sides would be delivered by hydraulic pistons. But there is also substantial, this includes about 13 radio frequency presses, which are interesting concept because they allow you to cure the adhesive at elevated temperatures. And then you don't need to press the entire area at times, but they press one segment at a time, curing it under radio frequency for about 5 minutes, and then moving this entire layout forward. So this is the hydraulic presses. Pneumatic presses operating in more or less the same principle, but the power is being the pressing power is being delivered by pneumatic pistons. But then vacuum presses. This is an interesting concept that I'm going to explain a little bit. I was personally surprised when I first started on this quest. I thought that the vacuum pressing is a footnote of history of development of CLT. I would tend to think that there is not enough clamping pressure. The typical clamping pressure is about 150 psi for this hydraulic and the pneumatic presses. Now, by comparison, atmospheric pressure is about 15, 12, right? I can't remember exactly what it is in PSI, but for this would be about 100 kilopascals, so 1/10 of a megapascal. This would be 1/10 of what is being exerted in these presses. Can you get a good product out of this? Well, apparently 25% of manufacturers believe they can. And they exist for long enough to prove that it is possible, and they pass local standards for quality. In terms of the brands, and here is an example where I got a agreement from all of these manufacturers to share their names on this chart. It'll be Ledinek, about the Slovenian company, about 90%, Minda, about 23%. Fankhauser is the manufacturer of this vacuum presses, about 16%. Kelso is the manufacturer of this RF presses, about 10% of the market. So you see, the market is, we should not say dominated, but it's increasingly the dedicated manufacturers of specialty hardware are taking greater and greater slice of the pie. It used to be that the field was dominated by do-it-yourself presses. The manufacturer would design a press that they would think would work for them and just order this press to be assembled for them. You can still find a lot of them. And there is, of course, a margin of operations for which I really don't know what they operate. This is vacuum press. Essentially, it looks like a big wading pool with a silica. Yes? Is there a question? No, I don't hear a question. Okay. With a silica blanket that allows, that is being wrapped around the layup in here. And the air is being evacuated and just atmospheric pressure uh, uh, assembles or presses the elements together. This could be done that way or in a very smart way. The best company that operates it, that I've seen, operates as many as 18, close to 20 of these presses that they can cut off the vacuum and stack presses one upon another. How I'm doing time-wise? I probably spent too much time uh, on some of these items. In terms of the press sizes, there seems to be like a sweet spot that is being driven by what can you put on the highway without additional penalty, not generating something that would count as a oversize load. On the other hand, it needs to be viable for construction. So there is certain minimum size that beyond which it would not be practical to produce these panels. We've been there. The difference here, this pie chart show you difference between a number of presses installed versus how much they contribute to the production. Let's go to the next one. Binders, adhesives, again, being talked about quite a lot. And then again, there is no magic about adhesives. That pure the polyurethane adhesives holds the majority of the market by number of lines operating it or by the volume. Comes just from historic development. They were the first to deliver a cold curing adhesive to this industry. So many operating manufacturing clients would adopt this adhesive first, and then it takes time, effort, and money to switch to something else. But increasing part of the market is taken by the urea-based adhesives, which allow you to cure this adhesive at elevated temperatures. This is where the share of the market that the Kelso presses are taking. And small amounts of other adhesives. But adhesives are not the only binders. As I said, the panels are being bonded by nails and by dowels. And there is like certain margin for unknown. So this is how the share would look like if we include these mechanical binders in there by number of operations. However, if we look by the production capacity, this would be relatively minuscule slice of the market. Still, majority of panels, cross-laminated panels, are bonded with adhesives. This use of adhesives and binders varies widely by region. And if there are questions on this, we can return to this thing. The next differentiating thing is like the business model. This would be an outline of typical commodity supply or value chain for engineered wood products, right? There would be linkages to harvesting, primary processing, industrial hardware, which is necessarily part of these adhesives if these products are adhesively bonded. But then what happens to the product is not the manufacturer's business, only as much as they need to know what should be the quality. It's the users who decide how to use it, okay? Now, it's very different with mass timber panel industry. Contrary to the popular belief, prefabrication enables the mass timber panel industry, not the other way around. This is why this patent from 1920s could not turn into a viable business until now. You need the ability to CNC these large pieces with a level of precision to turn them into viable elements for construction. So this necessarily integrates the elements of mass timber design, manufacturing technologies, and construction, because in order to manufacture these large behemoths and cut them to prefabricate them for the design, you have to have the design first. This makes it into a non-commodity product, essentially a specialty product. No panel is going to be made or pressed until you have a design finished to the minuscule detail. So this is a problem and an opportunity. One of my favorite quotes in here: it used to be that you either shop fabricate unique objects or mass produce very repeatable elements. But then with emerging of the CNC capacity, we can mass produce very customized or semi-mass produced very customized elements, right? And all of them to very quite specific orders. This is what is unique for this industry when you compare it to anything else in forest products. So generally, again, if we compare it to the typical commodity type of structural products, construction is just one of the many options in which these products can be used. And construction is remote, but a couple levels by quite a distance, right? From it's quite different with mass timber panels. Part of the supply chain for mass timber panels must be architectural engineering design, project management, but also what happens on the construction side. So typically all of these participants of the supply chain would be involved in the project early. I mean, both the manufacturer, architect, and the contractors would sit at one table and try to figure out what is the most efficient way of designing this thing for manufacturing that would of panels that would work best and most efficiently for a given project. And this would be repeated from project to project until you get to a typical project that could be repeated many times. So if CLT may become a commodity only in the second degree as having commodity type of project. This creates strong incentives for vertical integration. And again, for what comes from our surveys and interviews, many companies are vertically integrated. And this incorporates both things on the green part of the integration. Many CLT manufacturers not only have the sawmills, but actually are involved in harvesting and ownership of the forest lands, but that they're also involved in design and in the construction. Typical models of the vertical integration would be either coming from the design side, right, or incorporating the green chain in here, while the other parts would be optional, but there would be a number of companies that would incorporate elements of this, again, under the same roof. Speaking of business model, this is a map ripped from the Holz one here. I mean, this would be like wood from local place. It's a website, German website, that for each place in Germany allows you to see what are the closest forest products companies around your place. And then you can select by the type of the companies. So here I selected for CLT and mass timber, essentially, right? So you see sites in 200 kilometers radius from Nuremberg, okay? This would be the number of companies that either manufacture or design or build with mass timber. This inspired me to look at the data that I collected in similar way. If you look at the place that manufacturers, here would be Mercer, former Catera in Spokane, CLT, how far they are from the closest urban center of 100,000 inhabitants or more, and how far they are from the closest raw material source, that being a sawmill. And then if you aggregate it across region, you would have average distance to the nearest sawmill. This would be average distance for North America, and average distance to the nearest urban population center. You see that this shows a tendency of a company locating themselves closer to the raw material resource than to the place where they deliver projects. And then if you do this exercise across regions, you would see immediately the differences. The orange bars would show distances to the closest urban center. This would be where the projects can go, the reliable source of orders. And the blue bars would show the distance to the closest sawmill. This does not necessarily mean that this is the sawmill from which they get the raw material actually, right? But it tells you by average what is how companies see the balance. And you see how widely this can differ by region. If we take it somewhat further, what would be the population, not just at the closest urban center, but how much people would live within the 50-kilometer radius of the operation. Speaking again about the opportunities for projects, and you will see that here actually, surprisingly, the differences would not be as stark, right, as with the actual distances. If we look further, this is how this would compare percent of the sawmills and percent of the resource base within this reference radius. This takes us to another thing. If you put it on the scale where the distance to the closest sawmill and distance to the closest center are put on this graph like this, and the size of the blob would show the annual output in cubic meters per year, right? So a proportion. You'd see Central Europe being here, the rest of Europe here, North America here, Asia Pacific, South America, South Africa, and you would see there seems to be something like a trend, right? But this may be somewhat misleading. If you take a look at where the individual companies may be, right? All of these gray dots are all individual companies for which we know this data. This is kind of blurry, right? And again, the size here would show the annual output for individual companies. Now, the next interesting thing would be what would be the largest distance or the average distance for which companies deliver projects. This one can only be taken from what the companies brag about, and they typically have a list of the most advanced projects on their websites with locations. So it's relatively easy to track. So here on this, you would see as much data as we have for now for Central Europe, Asia Pacific, and South America. We are collecting these numbers for others. And this would be based on how many companies and how many projects. We could not possibly do it for all companies. Not all companies publish this data. So 3 to 4 from region, and we would mark the maximum distance and the average distance. So Central Europe can send their projects as far as 15,000 kilometers away, right? This would be the max, and substantially farther than any other region by average. Now, how much is 15,000 kilometers? Okay, perhaps closer in miles, over 9,000 miles. What? Okay, 9,000 miles, that would be actually distance between Vienna in Austria and Melbourne in Australia. And this is true. Actually, the European companies build projects in Australia. This is Melbourne a project in Melbourne executed by one of the Austrian companies. And this is another one in Brisbane, right? This is what happens. Projects are portable. Projects are portable. This is one of the takes away. So to conclude this thing, message for the AED folks in the audience. You're at the new frontier. Don't take anything for granted. Nothing is really set in stone yet. The integrating of the design, fabrication, and assembly should be taken very seriously. Talk to your manufacturer, talk to the contractor, do this work together. Design for assembly. The easier the assembly, the lower cost for the project, the greater accessibility, the greater volumes are going to be produced. We don't think about it too often, but design for retrofitting. What's going to happen in one of these walls inside is going to be destroyed by fire, flood, whatever, right? Designed for deconstruction and for reuse. I mean, this is important because CLT buildings are not forever. They are not like pyramids, right? So as we see the progress of the production capacity, at a certain point, 50 years since production, we will start deconstructing these buildings. The buildings are going to be decommissioned for whatever reason at the same pace. Somebody is going to thank you. Your grandchildren perhaps are going to thank you for doing a good job for designing for the construction. Design for masses. Don't think white unicorns. In one of my favorite places for CLT, a small town of Bekwe, 80,000 inhabitants. At some point, it had more CLT big CLT buildings per capita than any other place on this globe, right? Most of the buildings are apartments. This is advantage of building boxes. You don't need to construct like very intricate hybrid buildings where beam and post are executed in steel or concrete and only floor panels in CLT. Everything can be CLT in here. Walls and floors are load carrying, right? This is a big advantage. Models. This is a future for commoditization of the industry, in my humble opinion. Think of this. Closer to home, this is Ben Kaiser explaining this Model T for modular relief housing that can be produced in series, right, on production line. Think of durability by design. Don't believe that some chemist magician is going to turn your daring design into something that is going to survive ages like pyramids. I mean, do what Vikings did. I mean, provide the durability by design, protect the fiber from the exposure. This would be coming from the same Sweden, bad example, right? But coming from the same Sweden, example how they build to avoid the construction site being inundated with water or snow, right? The largest type of tent that I've ever seen was this one in the center of Bekwe. This is a large structure. It dominated the landscape of the little town. And this entire structure had been built inside, and all of this landing space for the incoming material would be housed in here. This tent doubles for 2 overhead cranes. So if you think of the cost of the tent, I mean, this is essentially also working for the as crane, and you pay for crane anyways. Why do not combine these functions? This is how the building looks like today. I would have, again, this is not the Viking way. I don't think the fiber is adequately protected in here by overhangs, but I'm keeping my fingers crossed. This is how the tent would look like from afar on the skyline of the city. So again, design for the future, right? You're in the new frontiers, think about it, design for the future. The message for the day is this industry is really young. There's still many things that need to be decided. It's still boutique small. So even small changes, brilliant inventions can move the entire industry to very different direction. Anything is still possible. Well, almost anything. And I would like you to leave with you with this message. Thank you very much.
Thank you, Lech. That's great. Well, you covered a lot of ground there in a lot of detail and lots of charts and graphs I've never seen before. So appreciate that. Thank you. There was one question early when you were speaking, and there wasn't a good chance to ask it then, but it was from Carlos Lee. And when you were talking about the failures or, certain factories closing and then reopening under different ownership, the question was, did the CLT companies estimate the markets and their growth?
That would be difficult to say. So companies are famously secretive about what brought them down, right? There's nothing to brag about. It is possible to research the root causes. I would be tempted to try, if I ever get to do such research, I would be tempted to try to find commonalities between these failures. But um, but this is not information that would be easy to find. Of course, the theories abound, right? You go to the trade gossip columns, trade journals, and you would see a multitude of theories of why uh, any given company has failed. The most I wouldn't even say that what the what the participants, people who have been through these failures tell you, right? There's always something to there are secret sauces in this. Yes.
Yeah. I mean, it does seem like knowing anecdotally what we know about certain companies in the US, for example, there are quite different reasons that the companies didn't continue. And I think also there's sort of wide acknowledgement that there's been a sort of a misalignment, I guess, of demand and capacity, especially in the United States as mass timbers become popular. Right in the early days, we had a situation where people wanted it, but there was only one certified supplier, and then there were long waits for products, and that sometimes turned people off using mass timber again because the projects were delayed while they waited for materials. And then as more capacity came on stream, we may have gone into a lull because of interest rates and tariffs and that kind of thing, and that swung things the other way when we had a lot more capacity. So, I mean, I guess it's a fluid economy, isn't it?
Yes, and then it's actually the economy 101 that if demand so much surpasses the capacity of the industry, the prices go up, right? So it makes CLT construction expensive just because it's so difficult to get your spot. And then it makes it a little less viable option for many solutions. But it does not have to be that way, right? And there are ways of resolving this glut just by rethinking of what the companies, what the businesses should be chasing. One risky white unicorn after another risky white unicorn that takes multiple years to develop on the design side, fabricate and put together. Or do they pad the spaces between the white unicorns with projects that are relatively easy, certain, low risk, bringing money?
Yeah. Interesting stuff. Does anyone else? We are at like 5:24, so I do want to wrap up by 5:30, I think. But if anyone has a pressing question they'd like to ask right now, please go ahead and unmute or pop it in the chat and we'll look for it right now.
Okay, I see a warning that we are at 5 p.m., but I did not see chat. So the interesting thing is when you're doing Zoom, your computer clock disappears.
Yeah, I'm aware.
Like
Don't worry.
left without any devices and with nobody being kind enough to tell me what the time is, I just went on.
Have you, maybe I'll just ask one to close is, in your travels around the world looking at these factories, I mean, have you been like, without wanting to, disclose anything that you were supposed to keep anonymous? I mean, was there any particular approaches that you saw anywhere that you were really surprised by or thought that they were particularly innovative?
Well, I'm surprised. Essentially, every other company that I see, every second company that I see surprises me and shows something in whatever, either the technology of the manufacturing floor or the approach to sourcing raw material or the placement in the supply chain that I never thought about before and surprises me completely. And this is actually what triggered this entire quest to see more and more of these plans. I thought that I would see three and I'll be fine. The first three that I saw did not fit in anything that I knew before about CLT, what I have read about it, what I've seen in any type of documentation was like completely off the charts for me. And I thought, okay, I'm going to find this regular one, the standard one. And it never happened. There is no standard one. There are some that are becoming more and more similar because of the hardware manufacturers that deliver more typical solutions. But then when you ask the companies what they do with this material, how they interact with the designers, with contractors, there's going to be, again, a plethora of possible solutions. And it's like this bubbling, evolving thing. And what's going to come up with this is for anyone to guess.
Yeah,
That's what makes it exciting and interesting.
sure, yeah. We have two more questions popped into the chat, one by I. Brennan. Is there any interest in standardizing panel sizing within the industry? Each supplier being different is a hurdle for design industry adoption. Will we have the 4 by 8 sheet of CLT equivalent?
I respond with anecdote. I mean, at the beginning of my quest, the fourth CLT manufacturer that I've ever seen in 2010 was Stora Enso. Back then, like the second new facility. Uh, this made back in the day Stora Enso the largest manufacturer in the world. And I said, now finally we are in the position when we can dictate the standard sizes and make this entire business into commodity. And this was in 2010 or 11.
Mhm.
We're 2026. It has never happened. The same Stora Enso, which now has like four facilities in Europe, they cannot enforce it. There are intrinsic barriers, and the primary thing is the panel itself is too large, too heavy, too bulk, too expensive to deliver it, to produce it to stock. And then when you produce in standard sizes, then somebody needs to fabricate it to whatever they need, cut substantial portion of this expensive panel. It is way, way more efficient to wait with the manufacturing until you have the design and then fabricate from scratch, lie up to exact sizes of what you need.
Right. And I just, as you know, like, because I interviewed you, I just interviewed a bunch of people for a graduate course that we're developing on mass timber industry. And I asked a similar question to what was just asked here around, are we going to, is there a need to standardize? Would that help with adoption? And some people said yes. And some people really thought that, the manufacturers being allowed to have their own dimensions and spans and so on, use different species, that was actually part of their competitive advantage and that, that was actually healthy. So it's kind of interesting, the breadth of opinions on that. I've got one more question from Todd,
Okay.
and Todd Bayerther, who's here with us still.
Hey, Todd.
And Todd says, what one problem in the industry do you think needs the most attention or that you would most like to research?
The closest to my heart and where I really see a lot of the current issues, particularly for the North American sector of this industry, could be solved is aim not try to commoditize the panels, but try to design typical, easy, low risk projects that would build similar structures across the landscape, be that schools, chain hotels, um, affordable living spaces where you don't need to hybridize. You can build everything out of this one product, panel, load carrying panel, where the manufacturer and small team of designers can take care of most of the process, and where the learning curve for the contractors would be quick and efficient. And once they learn it, they could repeat the same project again and again and again. This is going to bring volume, and this is what is going to bring revenue to this industry, reduce risks, provide predictability, essentially benefit the market. This is where I would like to. This is what I would like to happen. Whether
Yeah.
this is modular, volumetric modular, flat modular, does not really matter. But developing a project that could be, or a small portfolio of safe, low risk projects that bring revenue to the industry in between white unicorns.
Yeah. Yeah.
Thank you, Lech. Good job.
All right. Well, I saw a couple more comments in the chat, but we do have to close now, I think. So thanks everyone for staying on with us, and thanks especially to Lech for putting this presentation together and talking to us today. Really appreciate you sharing all this stuff, Lech.
Thank you for bearing with me over this now probably twice as long as I was commissioned to speak. But again, nobody was showing the clock to me, so
Oh, we got good value for money, so thank you.
I'm just pushing the blame, and that's very
All
good.
right. Thanks, everybody. We'll see you. You look out for future announcements about future meetups. I think we're going to do one in March because everybody is going to be at the Mass Timber Conference in Portland, I guess. But we'll be back, I think, probably in April, right, Parker, with something else, which you'll hear about shortly. Thank you very much.